Hey guys, in this video, we will compare and discuss the difference between 1, 2, and 3 address machine instruction. At first, let's see some examples on address machine instruction in different formats. In 3 address machine, we could see that we could imply the instruction using 3 memory location or 3 registers. So, if we see an instruction like addition, we could see that we could add y and z and then store the data inside x. Or in the multiplication, we could multiply z by y and then put the total value inside x. In 2 address machine, the same instruction are constructed using only 2 variables or only 2 memory location or CPU registers. So in the addition, in the 2 address, we could add y and x, but we have to save it to either one of these memory location or registers. So when we add y to x, we have to save it back to x or y. In this situation, we save it back to x. And the same for subtraction and multiplication and division. For one address machine, it's a little bit different because all the arithmetic operation should be done inside the AC register. So we use load to load the data from the memory inside the AC register, and store, we use it for saving the data from the AC register to a specific location at the memory. And then when we want to use addition or subtraction or multiplication or division, we should put add followed by the number or a memory location, and that will occur to let's say if we want to add m, so m will be added to AC and the total value will be saved at AC again, which is the AC register, which is the accumulator register. Now let's see how could we write this equation using different address machine instruction format. The question will be y equal to a minus b. Now if we see the 3 address, we could notice that we have a 3 memory location or CPU registers. So when we want to do the subtraction, we could write sub y comma a comma b, and that means that we will subtract b out of a and then save the total value inside y. But in the 2 address, we will subtract b from a and the data will be saved at a, and then we will use move to save the data from a to y. For one address, we could notice that we use load. So load a, it's mean that we should take the data from the memory A and then save it inside and put it inside the accumulator register, and then subtract B from the accumulator and save the data inside the accumulator again, and then store the accumulator data inside Y. Now let's see if we can apply this arithmetic operation using different address machine instruction. Let's just try to apply the arithmetic operation using one address machine. At first, we will start by loading the F value or the value inside F memory inside the AC register, and then we will multiply E by the last AC value, which is F, and save it back into AC. So the AC will be equal to F multiplied by E. Then we want to store the accumulator value inside X. So we use store X to store the accumulator value, which is F multiplied by E inside X. Now we want to load D. After we loaded D, we want to subtract X out of D. So the new accumulator value will be D minus X, which is D minus F multiplied by E, and we want to save the whole thing inside the accumulator. And then we use store X to store the value of the accumulator inside the X again. After that, we load C and multiply it by B and save the value inside the accumulator, and then add A and save the data inside the accumulator again, and then after adding A, we could see that inside the accumulator we have the first part of our equation and the second part are already stored in X. So now we have to divide the accumulator value by X and then store the data from the accumulator value inside X again. Now let's go to the second or the two adders machine instruction. At first we started by multiply F by E and then the data will be stored back in E. That's how two address machine works. We only have two register or memory location inside the instruction. So after we doing the operation, we should save it inside the first memory or register location. So when we multiply E by F, we save the total value inside E again, and then we subtract E out of D. So after we do the subtraction, we put it back inside D. And after that, we do the multiplication between B and C and then add B to A. Now we could see that A contains the first part of our equation and the D holds the second part of our equation. Now all what we have to do is divide A divided by D, and then the whole result will be stored back again in A. And then because we wanna store the data at the end inside X, so we have to move the value inside A to X, or to copy A data to X. So we use move X, A. And now let's try to do it in three address machine. At first we could see that in multiplication we have three variables or three memory location or CPU registers that we could use. So actually we could do the multiplication between two memory locations and then put the total of the multiplication in whole another memory location or register. So now let's see the multiplication. At first we multiplied E and F and then stored back inside E. After that we subtract E out of D and then store the whole data inside E. So we write subtract then E, which is the register we wanna store in, then comma D, the first number, and then comma E, which is the second number. Now let's go after that. There are a multiplication which is between C and B, and then the data is stored inside X. After that we add X to A and store the whole data inside X again. Then if we could see, the E holds the first part of our equation and X holds the second part of our equation. So now all what we have to do is divide X by E and store the whole results inside X again. That's the whole thing. Thank you for watching.